Welcome to part 5 of Competency 16. In this video, we will work with the fundamental counting principle, combinations, and permutations. Number 1. In a room of 9 Republicans, 7 Democrats, and 4 Independents, a special committee of 3 people must be created. The committee must have one person from each political group. How many different committees are possible? Okay, so we could also think of this first as, okay, what would the probability be for taking one person out of each group? Well, each of the groups has a total outcome, a total amount of people. So what we're doing is we're taking for the first group, we would take 1 out of the 9. Okay. And then for the next group, 1 out of 7, that would be the Democrats. And for the Independents, 1 out of 4. We're talking total outcomes. If we multiply these together, we would get a probability. But because of the way it's stated, what is the possibility? Okay, what are the total possible? That should have given us a clue that what they're really asking for is total outcomes. Okay, so we just multiply the denominators together. 9 times 7 times 4 gives us 252. That would be the total possibilities, okay? All right, this is unlike probability. Now, if they'd asked also for probability, we have a setup. We could have calculated that. All right, so now let's look at number 2. It's very similar, okay? It says, a student is selecting courses for next semester. The student must take a course from one of the following different courses from each subject offered, okay? Now, what we need to see is that English, math, science, history, and education, as above with the political groups, you had 3 small groups. They were existing smaller groups. So these are our small groups. And from these small groups, okay, we have to create one, let's call it a group. It says, if the student is eligible to take any course, how many different schedules are possible? Let's think about it. That is like what we had before. We're creating one schedule, which is a grouping, okay? And this can be arranged in different ways. So how many different possible arrangements would we have for this one group? So we're taking the small groups and we from those we are creating one small one, but it can be created in several different designs, okay? So what are we going to do? We'll multiply all of these totals for each group together, okay? So 3 times 5 times 4, and just for visual sake, times 1, and then times 7, okay? Enter 420, which is correct, okay? Now, this can be very confusing from permutations and combinations. What we're taking into account is we're looking at total outcomes. And always remember to look for, okay, what are we talking about here? We're talking about a bunch of different small groups. Well, I want to turn that into uh one group. Well, I have all kinds of choices, ways that I could create those. You could have math first, or you could have history first. And from that, well, I want English first. But I have 3 things I could choose from. Okay, well, that could all look different. Okay, all right, now let's go on to number 3. Okay, as you see, we're moving from that total outcomes to combinations. Well, this is a bit different. So let's read number 3. From a group of 15 students, how many different groups of 10 students are possible? What we're doing is we're going from the one larger group to a smaller group, okay, a smaller arrangement. Well, think about it. From the fundamental counting, combinations are different. And another big thing we need to notice for combinations, yes, we're going from a larger group to a smaller group arrangement, but the order doesn't matter. They are not asking us to line up the students in a specific order. It's a general grouping. Nothing else is mentioned, okay? So we need to identify our N and our R. Well, of course, N is equal to 15 and R is equal to 10. So let's use our calculator to quickly get this value. So we have alpha window, and we need combinations because the order doesn't matter. So that's number 8. All right. So just simply type in 15, arrow over, type in 10 and enter, and there's our value. That, and be careful with those threes. That's option C. I know your eyes could easily be drawn to B, but of course that's not what we need. Okay, so let's go to number 4 then. Okay, all right, and let's look at what they're saying here. All right, a school PTA has 11 parents and 7 teachers at a given meeting. If a committee of 3 people needs to be selected, how many different committees are possible? Okay, now that would seem like the fundamental principle of counting. Be careful. First off, we aren't pulling from 1 out of 11 parents and 1 out of 7 teachers. That's not what's happening. It's almost as though the wording is there to throw you or trick you. What's actually happening is this is a detail we just don't need. We don't care about. The point is that's 18 adults. That's just simply 18. Okay. So that's going to be our N. Okay. And now, if a committee of 3 people, really what we're doing here, it was forming a smaller group out of a larger group, and nowhere does it say that the order matters. Okay. Okay. So our R is going to be this 3. Okay. So now that I talk to you about it and, kind of realize, okay, hey, wait a minute. There's some info in there to try to throw us, to try to trick us. We really have a combination. They didn't say we're lining them up. They didn't say you need, 2 out of the parents and 1 out of a teacher, or you need 1 out of parents and 2 out of a teacher. That's not what they're saying. It's a combination in disguise. Now, here's one thing that we can do. We could say alpha window, okay? Or we could go back up here, capture our previous, push enter, and then just do a type over. It's kind of more trouble. Notice I'm pushing the arrow around. It's up to you. Do it any way you want to. Okay, so really what I need is to type over an 8. I'm going to come over, arrow over. I'm going to delete one of those digits, and I need the number 3. Okay, so that would be 18, 3. Uh-oh, I typed over 5 instead of 18. See, I probably should have just pulled it, from alpha window, but it doesn't matter. Let's push enter and see what happens. Okay, looks like we have D is our option. Okay. Yeah, it might have been quicker for me just to say alpha, window, number 8, type in 18. Oops, just arrow over, type in 3. See, it was actually a little faster. It all depends on what you feel like doing. Great, so let's look at number 5. Let's see what this is. From 25 available players, a coach needs to select a team of 9 players. If the players can play any position, how many different teams are possible? Okay, all right. Again, this is a combination because we have one large group to start. Okay, it's not like, number 1 and number 2, okay, where they had smaller groups and they specified. We're going from one large group to a smaller group and keywords, any position. This means order does not matter. Makes life easier for us. Simple combination. This time, let's go window alpha number 8 and simply type in. We need 25, arrow over 9, press enter. There's our possibilities, option A. Wow, that's quite a few possibilities. You don't realize until you calculate it. Okay, all right, let's move on to number 6, which will be permutations. Number 6, 10 people are lined up in a row to take a photo. How many different arrangements are possible? Okay, couple of key things going on here. Notice first, there is only one value, 10. We only have 10. No other conditions. Well, that means probably I'm very suspicious that our value N and our value R are the same thing. We are not pulling out a small group. We're just talking about the group themselves. Also, they are lining up. And we're talking about arrangements, okay? People are distinct. We're going to, meaning that we don't have a repeated person, even if they were twins, they're still an individual. And once they are lined up, that position is taken and they are taken out of the situation. Therefore, we must have a permutation that says 10 out of 10. Okay, so this is what we do. We say alpha window and we want number 7, and that is 10 out of 10. Okay, and push enter, and that gives us option D. So that is when we take all 10 people and we use them in a order that matters. Okay, all right, so when you see that kind of wording, it's pretty simplistic with your TI-84. Okay, so let's go on to number 7, where they add conditions and limit us. Okay, all right, so let's see here. It says 10 people are to be seated in a row with 10 seats in a movie theater. Okay, well, that starts out as 10 out of 10. 2 of the people do not want to sit in either of the 2 end seats in this row. Okay, let me draw this. Okay, so you go this way. Okay, oh, well, I probably could do better than that. As I tell my students, pretend I can draw. Okay, I don't know that that was any better. Okay, well, that's a row, and we have 2 end seats. Nobody wants to sit here. No one wants to sit here. Well, we have 2 people that say, I'm not sitting on the end. Okay. All right, so what does this do? This creates a condition. It actually reduces our group, okay? So in the middle, we have a permutation of only 8 seats. We're talking about the seats, not the people. The people are the large group that we're pulling from. Remember this, to think of this different from the first 2 questions, number 1 and number 2. Number 1 and number 2, we're talking about the smaller groups. That was fundamental counting. This is not the same. It's like instead of going from small to large, we're going from the large to the small. So we are creating 2 groups to discuss. What are our 2 groups we're discussing? Well, we have this 8. We have 8 seats, okay, and that would be 8 out of 8 seats available, okay? Regardless if we're talking about 10 people, okay? How do we accommodate for that? Okay, well, look over here on the end. On the end, how are we going to seat the people? Well, we have 8 seats. From the 8 possible situation, we're going to pull 2 out of the 8. Okay, so that would be, of the 8, we're pulling 2 out. All right, now think about it. You might have to sit and ponder this for a moment, but really what we have here, this is where your 10 comes into play. Well, how do we put this in our calculator? We're going to take those 2 permutations and multiply them together. Okay, that's 2 situations to get our 2 total outcomes. We have 2 smaller groups formed, and now we're just going to multiply the 2 total outcomes from the 2. Okay, so let's do that. All right, so I'm going to say alpha window number 7, and I'm going to say 8 out of the 8, arrow all the way over, say times, and alpha window number 7, and we still, oh, I did 8 out of 2 to start. I'm sorry, I actually wanted to do 8 out of 8. Okay, let's start with 8 out of 8. I guess it doesn't matter. But let's go now. Okay, that's the middle section. So now let's, out of the 8, we've seated all those 8, but we have 2 people left over. Okay, but we don't know who's going to sit there. So out of our 8 seats, we're pulling 2 out. So that would be 8 and a smaller group of 2. All right, so let's push enter. And that gives us option C, which is correct. I know you really have to think about what this means in order to get the total meaning. But the biggest thing to remember is think about it. It doesn't ask for probability. That's one clue. They're not asking me for probability. So it has to be some kind of a total outcome. But it's not the fundamental counting because they have a larger group of 10 people turning it in to 2 smaller combinations. But was it a combination? Oh, no, it's not a combination. We know that because the order that the people are seated is in a row, it's an arrangement. So that's kind of how we know what to do. Okay, this is the last question in this video. I hope it was helpful. And again, I want to thank everyone for watching and liking us, sharing us, and definitely thank you so much for subscribing. Happy testing, guys.